And 6.4 is about properties of rhombuses, rectangles, and squares. And remember, the key here is that these are special parallelograms. Means that every property we talked about with parallelograms still holds true for all three of these, a rhombus, a rectangle, and a square. So a rhombus is a parallelogram with 4 congruent sides, a rectangle is a parallelogram with 4 right angles, and a square is a parallelogram with 4 congruent sides and 4 right angles. In Theorem 6.13, if a parallelogram is a rhombus, then the diagonals are perpendicular. So along with the along with the congruent sides, the diagonals are perpendicular, okay, and they're going to form right angles. Okay, and if the parallelogram is a rhombus, the diagonals bisect a pair of the opposite angles. Okay, so angle 1 is congruent to angle 2, angle 5 congruent to angle 6. So they're angle bisectors as well. They're perpendicular and to each other, and they're angle bisectors. Problem 2 talks about what are the measures of the numbered angles in the rhombus ABCD. So we're trying to find 1, 2, 3, and 4 in this rhombus. Now, what they have and they give me is 58 degrees up here. Well, I know that the diagonals are perpendicular, therefore the measurement of angle 1 is going to be 90 degrees. Since this is 58, we know that this is parallel to here, okay? So we also know that 58 and angle 2 are going to be congruent because of alternate interior angles theorem. So measurement of angle 2 is going to be 58 degrees. Okay? Therefore, we also know that measurement of angle 3 equals 58 degrees. Okay? Because each diagonal of a rhombus bisects the pair. So angle 2 and angle 3 are bisected. So if 2 is 58, 3's got to be 58 degrees as well. Okay, so since we know 1 is 90 degrees, since we know 3 is 58 degrees, we can find 4. So measurement of angle 4 plus 90 plus 58 has to be 180 degrees because if you look, that figure right there is a triangle. Okay, so all the angles in a triangle equal 180 degrees. Add them all up. Measurement of angle 4 plus 148 equals 180. Subtract 148, the measurement of angle 4 equals 32 degrees. In Theorem 6.15, they talk about if a parallelogram is a rectangle, then its diagonals are congruent. So along with the 4 right angles, they talk about the diagonals being congruent. Okay, so in rectangle RSBF, SF is 2x plus 15. So the whole thing is 2x plus 15. And they give me RB is 5x minus 12. So we know, according to Theorem 6.15, that our diagonals are congruent. So I can take 2x plus 15 and set it equal to 5x minus 12. Again, subtract the 2x. So I end up with 15 equals 3x minus 12. Add the 12. I get 3x equals 27. Divide by 3, x equals 9. It's not what it's asking me. It wants to know the length of the diagonal. So just take 9 and plug it in one of the equations. So if we're trying to find RB, you could find a SF. It doesn't matter. RB equals 5 times 9 minus 12. Punch that in my calculator. You end up with 33.